Okie dokie. Um, another video for 9.5 on hypothesis testing. This one looks like it's going to be hypothesis testing for a mean here, but let's actually read the question to recognize this. So the average student loan debt is reported to be 25,000, 235. So your mean in this case, 25 to 35. Right, that's what the mean is claimed to be. That's like already prior data or prior analysis conclusion shows this. A student, some other person, believes the student loan debt is higher in her area. So student has a opposing claim, right? She takes a random sample of 100 college students and determines the mean student loan debt in this sample is 27,524, which by the way is such large numbers, it's crazy. And the standard deviation is 6,000. Is there sufficient evidence to support the student's claim at 5% significance? So what is our parameter, right? Our parameter is, I guess, mean student debt. That's what we are investigating. We're investigating mean student debt. So I already know my null hypothesis is going to be mean is equal to, my alternative hypothesis is going to be mean something, right? Requirements, right? Requirements, we need simple random sample, right? Random, oh yeah. And we need n greater than 30. Well, our n is greater than 30 here, so we click yes, right? N is equal to 100 by the looks of it. And now we have other data as well. Let's just write what that data is. X bar, their sample mean, 27,524. Our sample standard deviation, 6,000 here. Now let's go to testing the claim. We've done P, we've done R requirements. Now we're testing here, right? Determine the null alternative hypothesis, correct symbol and value. So we have mean is equal to what? The original supposed mean, 25, 25. And what is the alternative hypothesis? Student believe that student loan debt is higher than this value. So someone else is claiming, oh, yeah, it's bigger than that. Right? Now we have everything we need to use hypothesis test. Here we have the statistics already. We have everything kind of evaluated for us. We just need to plug this in the calculator. We don't have any data here, right? We have the statistics. So our sigma, which is our population standard deviation, that's always unknown. These are sample means and sample standard deviations. Sample standard deviation, 6,000. Sample mean, 1.7524. Sample size, 100. The mean associated with the null hypothesis, the assumed mean we start with, 235. And I'll note again, this is like based on prior assumption, like it's what people have reported before. Someone thinks it's different, does their own experiment and gets another mean, right? So there's two means we're kind of comparing here, but it should make sense. It's like, how do you have two means for the same data? It's like, no, this is like the prior determined average, prior determined mean. Someone's testing to see if that's still true, right? With today's area or today's numbers, we'll say. We said higher for the alternative hypothesis, and let me hit calculate. And look what we got here. This is the test statistic here. We use T for T distributions. I haven't really talked that much in class about that, but that is rounded to decimal places. So let's go 3.82. By p-value, 0.0001. That's the p-value in this case, because this data point, our statistics stuff, is so far away from the assumed normal that we're in actually what we call the rejection region. Like this shaded region here is the rejection region for 10% significance. The red stuff is rejection region for 5%, and this blue stuff is a rejection region for 1% significance. So we're already like in the rejection region for everything. But let's actually just compare it. Let's compare the p-value, which we said 0.001. Let's compare that to the significance level. So this is what alpha is. Alpha is equal to 0.05, which means my p-value is less than alpha here, right? We have, this is a lower number than this. P-value is less than alpha. What is that we do when we p-value is less than alpha? It means this is so unlikely to happen. It's more unlikely than the threshold we decided, which is 5%. It's so unlikely to happen that there's no way this is the actual middle. There's no way the mean was equal to this. There's no way we reject the null hypothesis. That's why you reject the null hypothesis here. Write a conclusion. There is, because we're saying this is not true anymore, we're saying there's significant evidence to support the claim that student debt is higher than that amount. We're saying there's no way it's equal. We're kind of in the bank, or we're trying kind of behind this hypothesis, the alternative hypothesis. There's significant evidence to support the claim that the student debt is higher than that value. And bing bada boom, looks like we got it all right. Heck yeah. Thanks for watching.